Welcome back to geometry. We're at section 8.1, which we are now involving trigonometry and trigonomic ratios. And so the first term that we see here is a term called SOHCAHTOA. Now what I want you to understand about SOHCAHTOA is that this is called an acronym. And what an acronym is if you can think back, probably in 6th, 7th, or 8th grade, we learned about PEMDAS, okay? And PEMDAS is an acronym. P stands for parentheses, E stands for exponents, M multiplication, D division, A addition, S subtraction, okay? And so that's the same thing that we have with SOHCAHTOA. The S stands for sine, and sine is going to equal the opposite side or the opposite leg over hypotenuse. The C is going to stand for cosine, and that's going to equal the adjacent side over hypotenuse. And then tangent, T, is going to equal opposite side over adjacent. And so the reason why we have this is that it helps us for us to remember sine equals opposite over hypotenuse, cosine equals adjacent, A, over hypotenuse, and then tangent equals opposite over adjacent side. Okay, the other thing that we need to know is that when we deal with sine, cosine, and tangent, they are side length ratios of our right triangles. Now, the only time that trig works, we can only use trig when we have a 90-degree or a right triangle. That would be the only way that we can use trig. So if we have an obtuse triangle, we can't use trig. If we have an acute triangle, we can't use trig. It only works if we have a right triangle. Then we can use sine, we can use cosine, we can use tangent. So as I look at this first problem, when it says sine of A, and sometimes you'll just see it as sin, which means sine of A. And what this means, bless me, when it says sine or sin A, it really means sine of angle A, which is what we have here. And so from this angle A, we look at the side opposite of angle A, which is here, and the side, and then this side would be our hypotenuse, because it's always opposite our 90-degree angle. Alright, so if we were to plug in values, here we have sine of angle A, and so again we look at sine of angle A, and it's going to equal the opposite side over hypotenuse, which is going to be 3/5. Alright, so this is the ratio of sine of angle A. Now this doesn't mean a whole lot to you now, but it will later, and here's why. On a scientific calculator or your phone, you can enter in second sine, or the inverse of sine, so it's sine -1, and then when you enter in 3/5, it's going to give you an answer that's going to be in degrees, which means that you can actually find this angle measure. And so let me grab a scientific calculator. Let me hit. Alright, so when we enter this into our calculator, we're going to get 36.9 degrees. And so what this allowed me to do was to say, okay, I now know that this angle is 36.9 degrees. Now let's do the same thing on cosine of angle A. From cosine of angle A, it's going to be the adjacent side, and we have two sides that are the same side as angle A, but recall that side 5 has to be hypotenuse because it's opposite our 90-degree angle. So that's why for the cosine of angle A, we get 4/5. Alright, now let's enter in second cosine of 4/5, and it should equal 36.9 degrees again. So let's enter that in. Second cosine 4/5 equals, and lo and behold, it's the same value, as it should be. It should be 36.9 degrees. All right, I'm also going to add, let's do the tangent of angle A. And so the tangent of angle A is going to be opposite 3 over adjacent, which is going to be 4. And just like I did before, let's enter in the second tangent of 3/4. And when I enter that in, I get 36.9 degrees, as I should. And so that's why we use trig. All right, we're using trig to find the interior angles. We can also use trig, we'll find out later, to find the side lengths of right triangles. All right, we're also asked to do sine of angle B. And so we have sine of angle B, which is the opposite side, 4 over 5. And if we were to enter in second sine of 4/5, let's do that right now. Second sine for fraction 5, and we get 53.1 degrees. And that should make sense as well, because if this angle is 90 right here, then these two angles have to add up to 90 as well, because we have 180 degrees in all triangles. And again, if we were to enter in second cosine of 3/5, we would also get 53.1 degrees. And last measure, if we were to enter in second tangent, or first, let's do the tangent ratio of angle B. That would be 4 over 3. And if we hit second tangent 4/3, we would get 53.1 degrees as well. All right, we finish up with a theorem that we've seen many times before. It is called the Pythagorean theorem. It works on right triangles. So let's include that in our notes, right triangles only. And if we have a right triangle, we can say a squared plus b squared equals c squared, where c is our hypotenuse. All right, and then a and b would be a height and a base, or leg and a leg. All right, we also have a theorem that says that if we were shown 3 lengths of a triangle, let's say we were shown 3, 4, 5. Okay, well, let's say that you were asked, will 3, 4, 5 form a right triangle? Okay, and the term for this is called a Pythagorean triple. And it will, because 3 squared plus 4 squared equals 5 squared, and we end up getting 25 equals 25, and that's true. So 3, 4, 5 is a right triangle. All right, so we know that the lengths of 3, 4, and 5 form a right triangle. What about the lengths of 3, 4, and 6? Well, if we were to try 3 squared plus 4 squared equals 6 squared, we would find out that 25 equals 36. So clearly these two aren't equal. This does not form a right triangle. But what it shows us is that if c squared is greater than a squared plus b squared, okay, so what we're saying here is that a was 3, b was 4, and c was 6. And what we find out is that 36 is going to be greater than 25. And so what is now formed here is that this forms an obtuse triangle. Okay, and so that will happen when we apply a squared plus b squared is equal to c squared, and they're not equal, and c squared is greater than a squared plus b squared, then we know we have an obtuse triangle, and so that would be a case of a triangle that looks like this. And that should make sense, because remember that a right triangle is always going to have a 90-degree angle. Okay, and so clearly this does not have that. Then it's also true that if c squared, and this time is less than a squared plus b squared, like if we were to look at a 3, 3, 4, we would get 9 plus 9 is equal to 16, 25 is not equal to 16, but we would see that a squared plus b squared is greater than c squared, Okay, then this is going to form an acute triangle, and so that would be where all angles are less than 90 degrees, so some kind of triangle that looks like that. All right, we're going to work through a few of these problems. We won't do all these, but just to kind of give you an idea of what we're dealing with when we have trig problems. So again, with trig, we really need to think of the acronym SOHCAHTOA. Whoops, sorry about that. Let's try that again. There we go. SOHCAHTOA. Okay, so everything revolves from here. Sine of angle A, we look at angle A, we see the opposite side of 40, and we see the hypotenuse is going to be 41. We look at cosine of angle A. The side adjacent is 9, the hypotenuse is 41. And tangent of angle A, we see the opposite is 40 and adjacent is 9. Now, one other thing that we can do is if we take the second sine of 40 over 41, we take the second cosine of 9 over 41, and we take the second tangent of 40 over 9, we should get the same answer for all three, and that answer is going to be this interior angle for angle A. So let's enter that in now. We're going to enter in second sine 40 fraction 41. We get 77.3 degrees. So what I've found here is that angle A is going to be 77.3 degrees. And if you enter in second cosine 9 over 41, you would get the same answer. If you enter in second tangent of 40 over 9, you would also get 77.3 degrees. So angle A equals 77.3 degrees. All right, next, the problems that will most resemble what you'll see on a test will be like problems 17 through 22. And for all of these problems, the more that you do them, you'll be able to do these in your head, and you'll find out that certain ratios won't work. Meaning, for every single problem, you have three choices that you can use to solve each problem. You can use the sine ratio, you can use the cosine ratio, you can use the tangent ratio. Okay, but only one of these will work when you solve for x. So just know that going into it, that you might make a few errors or a few missteps before you actually understand which one to use. So here's what I mean by that. Let's say that you were to try sine first, and I'm going to put side y here. Okay, if we try sine of 75, we get the side opposite, which is y, over hypotenuse, which is 39. Now, if on a test you were being asked for y, then sine would work. But you're not being asked for y, you're being asked for x, so we don't want to use sine here to solve for x. Okay, next, let's try cosine. Cosine of 75 degrees equals adjacent x over 39. And so this works. I don't have to use tangent. I see that I have x. I can put a 1 underneath here. Let's enter in cosine 75. We get 0.259. So 0.259 equals x over 39, and then over 1. And then we can cross multiply. 0.259 times 34. And that gives us 8.8. Alright, so x is equal to 8.8. Alright, next, for problem 18. Now again, I'm going to show you your thought process, and at some point in time you won't have to write all this down. You'll just do it in your head and you'll see it. And so again, we always want to think of SOHCAHTOA. Okay, this is our shortcut that we can use. So here's what I mean by that. When I start with sine, sine of 67 is going to be the opposite 30 over hypotenuse, which in this case, let's call y. Okay, and sine won't work here because I'm not trying to solve for y, I'm trying to solve for x. Okay, so we're not going to use sine. Next, let's try cosine. Cosine of 67 is going to equal x over y. And we have two unknowns, so we won't be able to solve for x, so cosine won't work as well. So that leaves us with tangent. I take tangent 67 equals opposite 30 over adjacent, which is x, and this time that will work. So we enter in tangent 67, which is 2.35. So 2.35 equals 30 over x. And cross multiply, so 30 divided by 2.35, and we get 12.8. So x equals 12.8. Alright, I believe you can handle the rest. Thanks for joining us. See you next time.